I'll talk about this new formula here in a second. Okay. First, I want to just try to do this. Okay. Now here we have a function inside of a function. Okay. The inside function, your g function, is x to the third plus 1. The outside function, your f function, is natural log of x. And actually, I've always been writing, f of x equals natural log of x, but if you ever see it in the book, they use a u. F of u equals natural log of u. So I don't know. I think that if you said f of g of x equals natural log of g of x, I think that would be better than the u, but anyways, different ways to write the outside function f, but that doesn't matter. So how do we do this? Well, we've got to use a chain rule. The derivative of the outside function is 1 over x, so that means we're going to get 1 over x squared plus 1. No, that's not a squared, it's a third power. Okay, so x to the third plus 1. So if we know that the derivative of natural log of x equals 1 over x, but look at what our x is right here. So this is just going to go on the bottom of a fraction. Then we have to multiply that by the derivative of the inside function. The derivative of the inside function is 3x squared. The derivative of 1 is just 0, so the 1 just goes away. So what do we get? What's the result? It's 3x squared over x to the third plus 1. That's the derivative of the first equation. Now this is why I don't think I need to prove or do anything with this function right here, because look at our result right here. The result is pretty much the inside function on the bottom and the derivative of the inside function on top. See, this says if you have a natural log and you have a function inside of it, your result is just going to be the derivative of the function on top and the function on the bottom. So this is I don't know, this is one of those equations, it's like a trick that you would have come up with on your own after you do the chain rule a bunch of times, like writing it out like this. You're going to get that anyways. But anyways, I'll still think about this one in terms of the chain rule, and then we'll look at the equation again. If you want to try the equation without doing the chain rule-ish, I guess, then try it. Now this one has 3 functions going on. It has the natural log, then it has the square root, and then it has the sine. There's 3 functions going on here. Okay, the outermost function is your natural log function, so we're going to do that one first. Alright, so the outermost function is natural log, so that means we're going to have 1 over what's inside. See, natural log of sine x. Okay. This is just the derivative of the natural log part. Then we have to multiply it times the next outside function, which is the square root. Oh, let me identify the functions really fast, because some of you guys really like that. So we have f of x. The outermost function is your natural log function. The next inside function, g, is going to be your square root function. The next inside function, h, the innermost function, is going to be sine x. So we first took the derivative of this function, which is this right here. Next, we got to take the derivative of the radical, the square root function. So we have to multiply it and see what we get. Instead of looking at it as radical sine, look at it as sine x raised to the 1/2 power. So we're going to drop the 1/2, then we have sine x inside, and then we have to raise it to the negative 1/2. Then we're going to multiply that times the derivative of the innermost function, which is going to be cosine x. Okay. Let's rewrite this right here, just because it has a negative exponent. It's going to be 1 over 2 square root of sine x. Actually, here, let me go slower there. Sine x raised to the 1/2 power, which we can write as 1 over 2 square root of sine x. So we have this multiplied times 1 over the square root of sine x times cosine x, which I'm going to put over 1. So now we can see what's on the bottom, what's on the top. Oh, we got something kind of neat happening on the bottom. we have a square root of sine x right here and a square root of sine x right there because we have to multiply all the denominators together. So what is square root of sine x times square root of sine x? Just sine x. And so on our denominator, we just have sine x, and don't forget that 2. He's right there. He's multiplying the sine x also. And on the top, we have cosine x. So in this case, I kind of like the chain rule better than this equation, trying to use this equation, because we had so many functions. We had 3 functions inside of each other right here. So this is, I don't know, it's easier for me to think about the chain rule than try to make up a new equation. Questions? Good call, Andres. We can simplify this. Look at this. What is that? What's cosine over sine? Yeah, tangent is sine over cosine. Cotangent has the cosine on top. So we have 1/2. So I took out the 1/2 times cotangent. Whoops. Which actually is just cotangent x over 2. Wow, I really like that. Got to notice those little simple trig identities.